18-8 and do 18.7 and hang on to your hats. Uh, we get into some little different concepts here when we talk about logarithms. And the reason for this, if you go back and you look at the ones that we did back here, if I kind of pull this chart over, okay, the trend line is a straight line, right? Okay. But in a lot of cases, we have lines that aren't straight. They're what they call it in the book is curvilinear. I think that's how you pronounce it anyhow. And I would refer to it maybe as exponential. Like the debt of the United States just kind of grows exponentially, right? So it's kind of, they got that curve up. The climate scientists, they tell you that that's what's happening to our climate, our weather, our heat or something. So in any event, what we look at here then, and what we have to do is figure out the logs and logarithms of certain numbers here. So let's download our data first. So we got our years here, and really they give us 2009 through 2013, but they're going to want us to solve for 16. So I just kind of went ahead and put those in here, okay? And then the sales, it gives us 1.1, 1.5. This is similar to your guys. I think your guys is maybe a little bit longer. Okay, and yeah, you got a little more data, but your solutions actually ends up kind of being the same. So then I put the years down in numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, because that corresponds to 2016. And now I just have to do the logarithm of these numbers here. Well, I know logarithm sounds kind of scary, but it's actually fairly easy, right? Okay, so I just come to my function thing, and I believe it's a mathematical and trigonometry. Let's go see if that's got log in it. There's log, and what we want is log 10. Returns the base 10 logarithm of a number. Okay, so what's the number? It's that one. Okay, copy that down until I get even with my 3.1 there, and there we go. So I've got my logarithms now for my base 10 logarithms for all of those. Now I just need to do my regression, okay? And this is my y and this is my x, but only do the x down, to the 5. And I'll do it real quick, just kind of show you, and I'll stick it on a different chart. So I got a regression, okay. My y input range is this. My x input range is the one I got labeled x. Got labels, yep. I'm not going to do the line fit plots, okay, and I don't need the residuals, because line fit, it's going to try to make it a straight line when it shouldn't be, okay. I'll just put this one on a new worksheet, and then we'll come back and take a look, just to kind of show you what happens here. Hopefully I got it right. Looks right. Okay, so there's the output, and then go back to the one we were working on. And what's that give us? First, it asks us to determine the logarithm trend equation. Okay, so the logarithm trend equation is simply just like we have anyhow, right? We've got the intercept. In this case, it's a negative 0.053 plus, because that's a positive number, 0.110 t. Okay, t or time. Okay, but then B, it asks us to figure out what the basically what the growth rate is what we're figuring out here, what the growth rate is, because if we got a growth rate of a certain percentage, that's what gives us that exponential. Whether it's a big or small percentage, we're still going to have an exponential growth. Okay, well, how do I get that? Okay, well, basically it's the inverse log of my x here, okay, or my log b. So the inverse of that, I believe that's what they call it, is the inverse logarithm. Let me make sure that that's what they call it. Yeah, it's anti-log. There you go, it's the anti-log. Well, how do you calculate the anti-log? Well, it's just 10 to the power of that. Okay, A log is 1/10 of, or the 10th root of a number. And so here we've got 10 to the power of this number. Okay, so I can simply say this is equal to 10 and use my y hat to this power. Oops, I got it right. Okay, boom. There it is. How do I get this? Well, this is simply equal to oops, I'm sorry. Simply equal to this minus 1. Okay, and put it in the form of a percent, and that tells me what my growth rate is. Okay, and that's good information to know. Now I want to calculate then, kind of calculate this equation. I got to figure out what 2016 is. Okay, and remember my equation is here. It's giving me the logarithm, or the log 10 number. Okay, and so if I plug it in, I've got my log y hat is equal to log a and log b times t, and so you know my it's equal to my log a plus my log b times 8 is the number that I'm looking for 2016, right? In parentheses. Should be right, I think, right? 0.83, yeah, I came up with a little different number. I got 0.827 there. I think I must have used a little longer or a little shorter. What did I use? No, I rounded it off, which is probably not rounded off here. So basically came up with the same number, okay? And I rounded this one off when I got here, so I got 0.827. Well, then I just have to find the anti-log of that, and that's going to tell me what my sales will be, or what my projected sales will be, basically if I continue with that growth trend. And so my anti-log is simply equal to 10, use the hat, over the 6, and that number. And I come up with 6.714. 6.7. Okay, a little bit. The work isn't hard at all. Kind of understanding the logarithms and whatnot, and what they stand for and whatnot is kind of meaningful. So there you have 18-8.